This question is called optimal hedge ratio, and it says you just bought one share of stock A and want to hedge it by shorting stock B. So we can call it J equals one share of stock B. How many shares of B, so H, I'm trying to find, how many shares of B would you short or should you short to minimize the variance of the hedged position? Assume that the variance of stock A's return is variance of A, and the variance of B's return is variance of B. Their correlation coefficient is rho. So how do we represent this position? We have some returns for A, and that can be our random variable. And we also have some returns for B, and that can be our random variable for B. So our position is represented then by how many shares of position A we have times its returns minus, because we're shorting stock B, right? Minus H times the returns for B. We said that we have one share of stock A, and so J is equal to 1, so we'll get rid of this coefficient here, because the same thing as saying it's 1. And we want to find the variance for this. There is an identity that we can use for the variance of adding and subtracting two different random variables, and that's the variance for this will equal it would have been, I'll put J for now actually so we can see what it would have been. It would have been J squared variance of returns for A plus H squared times variance of returns for B plus HJ covariance of returns for A, returns for B. But in this case, our H is negative, so we're going to put a minus sign here. Okay, now we can say, okay, J is equal to 1, so we can get rid of the J's. Right? So this is where we have to solve. This is our setup for the variance of this position. We want to minimize H, right? So we can do, well, firstly, we have this covariance, which is like an unexplained variable we don't have a variable for. So we have the variance for returns for A was this. So we can say variance for A plus H squared variance of B minus H covariance of returns of A, returns of B, and covariance of random variables equals the correlation coefficient, which we're given as rho, is equal to the covariance of your position of the two random variables over the standard deviation of A times the standard deviation of B. So if we move these over, we get the covariance for returns of A and B equal rho standard deviation of A, standard deviation of B. So we can plug that in right there, and so we get the variance of our position is going to be the variance of A plus H squared variance of B minus H correlation coefficient of rho. And then standard deviation of A, standard deviation of B. We want to minimize our H, right? And to do that, we're going to have to take a derivative with respect to H and set it equal to 0. Because as you know, to find the minimas or maximas, we take derivatives. And with respect to what? Well, these are all constants, right? These standard deviations and these rows and variances, these are all constants. Our only variable here is H. We're trying to minimize our H, so we're taking a derivative with respect to, we can take a partial or regular, it doesn't matter because it's going to be the same thing here. With respect to H of all of this, and set it equal to 0 to find some sort of plateau. And the plateau is where it's going to be equal to 0. Where the derivative is equal to 0. Okay. Now, we can solve for this. Well, this will go away. The first term goes away because it's going to be considered constant. Let me get 2h standard deviation of b minus h, oh sorry, no, not minus h, minus rho standard deviation of a, standard deviation of b. And sorry, there's supposed to be a 2 here. 2. It's going to be 2hj, and then we get rid of the j. 2 rho standard deviation of a, standard deviation of b equals 0. The 2's can cancel. We move everything over. So we get, we're trying to solve for h. So h standard deviation of b equals rho, or was it, yeah. This is also variance, right? Yeah, it was variance. So we move this over. We get rho standard deviation of a, standard deviation of b. We have time equals h times the variance of b. And then, so then we have h equals rho standard deviation of a, standard deviation of b over variance of b. And so we have h is equal to rho variance, or standard deviation of a over standard deviation of b. And now we have to check whether or not this is actually a min or a max. To do that, we take the second partial derivative of this. So we initially got 2h variance b minus 2 rho standard deviation of a, standard deviation of b. Now we take a second partial derivative, see if it's positive or negative. So again, ddh. And so we get, well, this goes away, and then the h goes away. So we get 2 variance of b, and the variance will be positive. And so yes, since it's positive, this is considered a min. And so this is our answer. How many shares of b we must buy such that we minimize the variance of the overall position?